In this lesson, we are going to be doing two things. We are going to learn how to identify a rational number, and then the second thing is we're going to convert between fractions and decimals. Let's talk about what makes a rational number. A rational number are numbers that can be written as a quotient of two integers. A number is rational if it can be turned into a fraction. So let's think of all the different numbers that can be turned into a fraction. I'm thinking of whole numbers. I'm thinking that a fraction can be turned into a fraction, or should I say, it is already a fraction. Mixed numbers. A terminating decimal, and I'll show you an example of this after we're done with this list. And also repeating decimals can be turned into a fraction. So these four things are classified as rational numbers because they can be written as a fraction. You can turn them into a fraction. And again, that's your proof. Your proof that something is rational if it can be turned into a fraction. So the first part of your work is them giving you a number, and you're going to decide if it's rational or not. It is a rational number if it can be turned into a fraction. So again, they're going to ask you, is this number rational? Prove it. To prove that this is rational, I'm going to turn it into a fraction. To turn any whole number into a fraction, I put it over the y. So yes, this is rational. The proof is the fraction. Or let's say I have negative 12. Is this a rational number? Yes, because I can turn it into a fraction. The fraction is the proof. They might give you 1/4. Is this a rational number? Yes, because it's a fraction. The fraction is the proof. They might give you a mixed number. Is this a rational number? Yes, because it already is a fraction. You could also turn it into an improper fraction. So 4 times 5 is 20, plus 3 is 23. This is negative 23 over 4. Yes, this mixed number is rational because it can be turned into a fraction, or it already is a fraction. Decimals are rational numbers because they can be turned into a fraction. Now this is a terminating decimal. Terminating decimal means a decimal that stops. This 5, there are no other digits behind it, so if it stops, it's terminating. We can also turn it into a fraction. 0.5 is 1/2. I'll show you how to convert that later on in this lesson. Repeating decimals are rational because they also can be turned into fractions. We're not going to learn how to do this in this lesson. You're going to learn it in the future, but 0.3 repeating is 1/3. Okay, so again, this lesson is going to ask you, they're going to give you a number. Is it rational? If so, prove it. And the proof is the fraction. Let me give you an example of a number that is not rational. The opposite of rational is irrational. An irrational number cannot be any of these. It can't be a whole number, it can't be a fraction, it can't be a terminating decimal, it can't be a repeating decimal. In fact, it can't be turned into a fraction. So I'm thinking of decimals that go on forever and ever without stopping. And I can think of one number in particular, pi. Pi is a decimal that goes on forever without stopping and does not repeat. Another example I'm thinking of is a square root of a number that's not a perfect square. If you put this in your calculator, you're going to see that it's going to go on forever without repeating. Alright, so let's start converting. And I'm going to convert from decimals to fractions. And in order to convert from decimals to fractions, you need to use place value. Let me remind you a couple places for place value. I'm going to go 3 places. To the left of the decimal is the ones place. To the right is the tenths. then the hundredths, then the thousands. Notice that these place values have a number in it. The tenths has 10, hundredths has 100. We're going to use that to change a decimal to a fraction. Let's say we have 0.13. What you're going to do is you're going to look at the last digit. Whatever place value is, that's what you put it over. So for example, this 3 is 2 places past the decimal, that's 100ths. We're going to put 13 over 100. We just changed a decimal to a fraction. Suppose you get a fraction like this, 0.8. Let's make it negative 0.8. Look for the last digit. It's in the tenths, so I'm going to put 8 over 10. This is a negative 8 tenths. When you get in a situation where you can simplify, you must do it. If you don't, it's going to be wrong. So I see the greatest common factor between the numerator and the denominator is 2. I'm going to divide them both by 2. I get negative 4/5. Let's say we have 1.6. So you're going to have a whole number out front and then numbers past the decimal. My suggestion to you is that you forget about the whole number for a second and work with the decimal. I see that I have 0.6 off to the side. It's in the tenths. So I put 6 over 10. This 1 to the left of the decimal is a whole number. When you turn it into a fraction, it is still a whole number. So 1.6 is 1 6/10. Again, you need to reduce it as much as you can. So here I see the greatest common factor between 6 and 10 is 2. So I'm going to divide by 2. And I get 1 3/5. Let's try negative 9. Oh, yep, negative 9.42. I have a whole number out front that I'm going to forget for a second, and I'm going to focus on the decimals. The last digit goes to the hundredths place, so I'm going to put 42 over 100. And then I'm going to bring that whole number out front. Simplify when possible. I see that the greatest common factor again is 2. So I'm going to divide both the numerator and denominator by 2. Okay, let's go the other way. Let's go from fractions to decimals. And I can think of 2 different ways to do this. The first way to do it is to use place value. And this is the shortcut. The opposite of what we were doing up there. So let's say they give us a fraction such as 19 over 100. Because this is a 100, I know that my last digit, this 9, is going to go in the hundredths place. So I get a decimal that looks like this. Or suppose they give you 3/10. I know that this digit, this last digit, ends in the tenths place. This is the tenths place. They might not give you fractions though that end in the exact places. So for example, maybe they give you 2/5. You have to ask yourself what you have to ask yourself is, can you make the denominator be a 10, a 100, or 1,000? Can you change it? Yeah. I can change 5 to 10 by multiplication. Now you're going to want to use multiplication, don't use addition or subtraction. I see here that I can multiply the bottom by 2, and whenever you do the bottom, you have to do the top. So here I get 4/10. Now that I have a tenths, I can put this right into the tenths place. Let's try another one of those. Let's try 21 over 50. I can't make this into a 10. I could divide, but do you see divided this would not come out evenly. So instead of division, instead of making this into 10, use a different place value. I'm thinking of 100. You could turn 50 into 100 by multiplying by 2. And whenever you do the bottom, you have to digit has to go in the 100ths place. Here's the hundredths place. So I just converted this fraction into a decimal. Now this shortcut works great when you give fractions that have a place value, tenths, hundredths, thousandths, or you can change the denominator to be tenths, hundredths, thousandths, but not all fractions are going to be like that. For example, what if they give you 3/8? I can't multiply to make this 10 or 100 or 1,000, so we have to have an alternate way to do this. And the problem actually tells us exactly what to do. We have to do 3 divided by 8. So the other method to turn a fraction to a decimal is to divide, and division will always, always, always work. So 3 divided by 8, I'm going to set up the division problem. Oops. So 8 does not go into 3. What I'm going to do is I'm going to add a decimal and a 0. 8 goes into 30 3 times. I have to keep working here. 8 goes into 67 times. And I have to keep going until I get a 0 at the bottom. 8 goes into 45 times. Here, 3/8 is the same as 0.375. Let's try another one. Let's convert. -7/12. You can check to see if you can do the shortcut first. The shortcut is given a denominator of 10, 100, or 1,000. Can't do it with this problem, so I have to use the long way, and the long way is division. So I need to check to see how many times 12 goes into 7. But it doesn't, so I'm going to add a decimal and a 0. Now I'm trying to decide how many times 12 goes into 70. That's 5 times. Okay. I can't stop until I get a 0 at the bottom here. 12 goes into 108 times. Keep on going. 12 goes into 43 times. Okay. 12 goes into 43 times. You're going to notice something, hopefully. This problem does not end up getting the 0 at the bottom. It's a repeating decimal. So when you get a repeating decimal, you write your answer. And the repeating bar represents the number going on forever. The repeating bar has to go over the first number that's repeating. So I realized that this number was repeating here. It's the 3's that are repeating, so I'm going to put it over the first 3. Now, get in a good habit of always checking the original problem. Here I see that the original problem was negative. If I wrote this, I would have gotten it wrong because I forgot the negative. So this is my final answer. I have one more for you. I would like you to try. Let's see. 3 and 4/25. Now I understand this fraction, you can use a shortcut because we can turn 25 into 100, but let's pretend that you forgot the shortcut and do it the long way. My suggestion to you is to forget about the whole number and work with the fraction. At the end, you can bring the full number out. So go ahead and try that. Push pause and try it. Set up the division column. 25 does not go into 4, but 25 goes into 40 once. 25, I'm thinking of quarters. There are 6 quarters in a $1.50, so 25 times 6 is $1.50. And I get a 0 at the bottom. So again, when you get your answer, be very careful. Always look at the original problem. If I just wrote my answer 0.16, I would get the problem wrong. I'm going to look at the original and see that we have a whole number. This stays a whole number. Negative 3.16 is my answer.